Okay, in this next section, it asks us to be able to determine how many valence electrons are in an atom, what its oxidation number or valence charge is, and its Lewis dot structure. So you're going to need your periodic table for this, and we will provide you with a class set. You will not be able to use your personal periodic table on the test. All right, we start and find neon on the table. He's one of our noble gases. When we go to the top of the column, we discover that he has 8 valence electrons. Because he has a full shell, he doesn't lose or gain any electrons, so his oxidation number is 0. His Lewis dot structure would be capital N, small e, and he needs 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Moving next to nitrogen, going to the top of his column, you find out he's in group 5A, which means he has 5 valence electrons. We're trying to get to 8 valence electrons, so nitrogen's going to pick up 3 extra negative charges, which will mean his oxidation number is -3. His Lewis dot structure will be capital N with 5 dots around it. 1, 2, 3, 4, 5. Rubidium's next. When you go to the top of his column, you discover that rubidium has 1 valence electron. The rule of thumb is if you have less than 4, you give away your valence electron. If I subtract 1 negative, I end up with a +1. Lewis dot would be Rb with a single dot. Potassium's in the same column as rubidium, so he will also have 1 valence electron. We're going to give that valence electron away, so we're subtracting -1, which leaves +1. His symbol is K, and he has a single dot. Helium's next. He's the exception that we have. Helium, recall, only has 2 valence electrons because he's on that first energy level, and it only holds 2. His oxidation number is 0. We wrote that at the top of the column. He's a noble gas, and they do not give or get electrons. His Lewis dot structure would be a capital H with a little e with 2 paired electrons. All right, moving across, we have strontium. Strontium is in group 2, so he will have 2 valence electrons. That's less than 4. He gives them away. If we subtract -2, we end up with a +2 charge. We have Sr as his symbol, 2 valence electrons. That's a pair of dots. Aluminum's next. Top of his column, 3A. His group listed as column 13, but his group is 3A, so his valence electrons is 3. Less than 4, he gives those 3 away. If we subtract -3, we end up with +3. That will be Al. He'll have a pair at the top for electrons 1 and 2, and a single on the side. Silicon's next. When you go to the top of his column, column 16, you find out his group number is 6A. That means he has 6 valence electrons. He's trying to get to 8. In order to get to 8, he's going to get 2 more electrons. That gives him an increase of electrons. He'll have 2 more negative charges, so he'll have a -2. Silicon will have 6 dots. 1, 2, 3, 4, 5, go back in pair, 6. Iodine's next. Iodine is in column 17, which is group 7A. Means he has 7 valence electrons. He needs 1 more to get to 8, so he'll take on an extra negative charge for -1, and he will be capital I, have 7 dots. 1, 2, 3, 4, 5, 6, 7. Magnesium's last. We find magnesium in column 2. That means he has 2 valence electrons. He's going to give them both away. Subtract -2 gives him +2. That's magnesium with a pair of electrons on the top. Okay, if we move down the page, we're going to pause here for a minute, move the page, and restart. Okay, in section 11, it asks us to find the information for the missing neutral elements. This is a repeat of what we did on our last test. If I am atomic number 23, I go to the table, I find the symbol is vanadium. Notice we've asked you for only the symbol, not the isotopic symbol, so we don't need mass number or atomic number. If my atomic number is 23, that means I have 23 protons, 23 electrons. In order to do neutrons, I'm going to do 51 minus 23 and get 28. The next one, I have 14 protons. It means I know I have 14 electrons. If I have 14 protons and 14 neutrons, I'm going to add them together to get 28 for the mass number. If my protons is 14, I'm atomic number 14, and that means I am silicon. The next row, we know your calcium. Atomic number is 20. I have a mass number of 40. If I have 20 as my atomic number, I have 20 protons. I'm neutral, so I have 20 electrons. And to get neutrons, 40 minus 20, or 20 neutrons. The next one, I have 12 electrons, which means I have 12 protons, which means my atomic number is 12, which means I am magnesium. To get mass number, proton 12 plus neutron 13 gives you a mass number of 25. The next one, I have 47 protons. That means 47 electrons. That means an atomic number of 47. That means I am silver, Ag. And neutrons, I'm going to do 108 minus 47 to get 61.